Good morning. Welcome to Making Stuff with Chris Dayhut in our segment titled This Maker's Tool. For today's tool, we're going to be taking a look at the dial test indicator. For those of you that have been following along since the beginning or watching this series in sequence, you probably remember me talking about a dial indicator just a few episodes ago. That's true, but this is a dial test indicator, and it's very important to understand the difference between the two. While their applications cross over, reality is they're very different tools. Dial test indicators, as their name implies, have a dial with graduations that allow for the accurate measurement of very tiny details. Through gearing, it can show you a man-readable value representing a very small distance. For example, you can barely see the thickness of paper, yet with the dial test indicator, you can easily measure that thickness and see the amount with the naked eye. Think of it as a visual distance amplifier on steroids compared to the dial indicator. This is a dial indicator. It is not a dial test indicator. The action is a plunger. You'll notice that this stem, as it goes in, working as a plunger, causes the dial to rotate. Through that mechanism, we cannot get very fine resolution out of this type of movement. And that's what really leads to the difference between a dial indicator and a dial test indicator. This is a dial test indicator. Much smaller, much more compact. It has these rails here, here, and here for mounting. They're called a dovetail mount. Often they come with stems that you can attach to them, or it attaches to another device. It works off of a lever mechanism, as you can see here, and you'll notice that a very small movement, that's all the travel this has, and you can barely see that, right? Well, if we look at the dial, that's the full travel. It doesn't have a lot of travel to it. Often these are only about 20 thousandths of an inch or a half a millimeter of full measuring range. Typically, these devices start their graduations at a half of a thousandths of an inch, or 0.0005 inches. The larger dial indicator starts at 1/1000th of an inch, or 0.001. This particular indicator is probably my cheapest indicator that I have that's in the test family. This one does go to 1/10 of 1/1000th of an inch, and in spite of its low price and everything, it's actually served me very well for the last 10 to 15 years. I've had zero problems with it. This particular dial indicator is made by a company, Brown & Sharp. This one dates back to about 50 years ago, just short of 50 years ago. It was one of my first test indicators, and its minimum resolution is 0.0005, or 5/10 of a thousandth, as we would say in regular English. This has been another very good indicator for me. It does have a very small stem on it. I remember replacing the original one, which was much longer, for a very special application, and I lost the longer one, but again, it's still serving me perfectly fine. And that is a feature of dial test indicators. We can put different stems on them. This particular one is very important to me. This is a brand name called Aerospace. These are highly respected in many industries for being a very high accuracy instrument Even though the aerospace seems to think it implies a specific industry, they are used by machinists all over the place and are often respected as some of the most precise instruments out there. This one is, again, same as the last one. Each graduation is 0.0005 inches. This particular one is my newest purchase. This one I purchased about 5 years ago when I went back into engineering for a machine tool company. And the purpose of that was so I could get back into teaching again, which is what I've absolutely loved my entire life. And I needed a dial indicator to help calibrate and set up the machines, and this was my choice. A nice large dial, white background with big numbers so these tired old eyes could see it. But another great high quality indicator, and this one is by Mitutoyo. Here is another one by Mitutoyo, and this is probably my most precise one. This one is a metric test indicator, and I don't know if I can get that clear enough on camera or not, but it's a 2 micron, so 0.002 millimeters per graduation. That works out to, in the English world, or I should say in the imperial measurement system, at 40 millionths of an inch. This one was given to me by a friend. It was not functioning when I got it, but I was able to take it apart, and I believe I've got it fully functional now by tweaking a little bit on the inside. And finally, this one is a newer Chinese-made 2 micron dial test indicator that I purchased, I'm going to say about 10 years ago. I had a need for one, and I didn't have one on hand, so I bought this, I think, off of Amazon. It wasn't very expensive, but I will say it has proven to be quite reliable and quite accurate. Like the regular dial indicator, the dial test indicator was invented by John Logan in 1883. These devices can measure distances, thicknesses, flatness, diameters, etc., and they can make static measurements as well as dynamic measurements. And often you will see them used by service technicians, engineers, and quality control people measuring the smallest of details imaginable. Measuring any feature smaller than what these devices are capable of, you are usually using some form of a light source device to make that small measurement, such as lasers or other types of light measurement techniques. As mentioned earlier, they measure to a very fine resolution or unit. In the US, most dial test indicators have a 0.0001 graduation and often have 20 thousandths of an inch of travel. And that 0.0001 we would commonly refer to as a tenth of a thousandth. In the metric system, a common size has a 2 millimeter range with a 0.002 millimeter graduations, which is, again, about 40 millionths of an inch. And when you're measuring at that small of an amount, everything's got to be in control, temperature, even dust gets to be a problem if you accidentally measure a clump of dust. At 40 micron or 40 millionths, everything is important. Let's take a look at pricing for these things. As you can imagine, these you just don't buy for 20 bucks at the local hardware store. As before, I'm using the Starrett website for price comparatives so that you get an idea of value. This particular model has a range of 60 thousandths of an inch, and it has a resolution of 0.0005 inches. So that would be 5/10 of a thousandths. And the list price on this one is $505. Another feature that I kind of noted earlier was the diameter of the dial. That is often very important for people, and this one has a 1 3/8 inch dial. Moving up in the accuracy range, this particular one has a resolution of 0.0001 or 1/10 of a thousandth of an inch. Its range is only 10 thousandths of an inch. The dial is 1 3/8, does have a black face, which again, that can be important for a lot of people for visibility. This one is $493. And finally, we're looking at a metric one. This one is a Starrett again with 2 microns or 0.002 millimeters of resolution, and it has a 0.2 millimeter range. And the dial is about the same as the other ones. Of course, it's listed in metric at 32 millimeters. Surprisingly, the price of this is lower than the other two, but yet it is more precise. So that's kind of an interesting thing that I noted while digging up this information. The dial test indicator is used where absolute accuracy is required. No excuses. Measuring play between 2 machine components or the runout of a rotating shaft are very common applications. They can also be used to measure the thickness or flatness of material when set up on a qualified surface. Here are a few demonstrations I put together for you so that you see the accuracy of it. In the first example, we're measuring the thickness of paper. If you remember on our dial indicator example, the needle only moved 3 graduations. Here you see the needle moving almost halfway around the whole dial. That's the type of amplification of distance that these devices give us. Then we'll move on to doing a comparative measurement between 2 shafts, one being the master, and we're comparing the second one against the first one, and we can see the difference between the two. And finally, where they're used very frequently, and I myself have been using them frequently in recent years, is measuring spindle runout or some other machine component to see if there's play or slop or runout or out of round conditions or flatness conditions. These devices will show you the smallest deviations. Surprisingly, this machine spindle, which was very economical when I purchased it, and it is now showing its age, still only has 3 microns of movement in it, or 3 microns of runout. All around, the spindle's still doing good for precision. Test indicators are not for everyone in every shop. In the world of hobbyists, it's very rare to need one unless you're into precision components and machinery. They have their purpose and application where they are a great choice to use. They are very handy for anyone working with mechanical machinery or anything that requires inspection and adjustments. For nearly 50 years, I have been using test indicators in various applications to measure the accuracy and precision of components, and that goes through all of my hobbies. Rare have I used a dial test indicator in woodworking, but I certainly used it in building race car engines and everything else in between since my early days as a machinist. With that, hopefully you got a little better appreciation for this little device called a dial test indicator. Thanks so much for watching, and hopefully you enjoyed this video. If you did, I'd surely appreciate it if you could subscribe, give me a thumbs up, and even maybe drop a comment down below to tell us what other tools you might like to see or what other information you'd like to see along the way. Thanks again for watching, and I look forward to seeing you in the next episode.
And if she's smoking cigarettes in the men's room, he wants to show her his new tattoo.